In last class, we have discussed the analysis of multi-degree of freedom system to some extent. We have not yet defined what do we mean by multi-degree of freedom system. We will do so in due course of time. Right now, we will go ahead with, we will accept that this is multi-degree of freedom system, and we will go ahead with free vibration analysis of multi-degree of freedom system. For that, I have considered an example where I have given you the values of M1, M2, C1, C2, K2, which are masses, damping coefficients, and stiffnesses associated with each degree of freedom. Are you with me?
Yes, sir.
And what are the degrees of freedom? So U1 of T is 1 degree of freedom. U1 of T is displacement of mass M1 from its mean position at given instant of time T. Happy?
Yes, sir.
Okay. And the second degree of freedom is U2 of T. So it is displacement of second mass from its mean position at given instant of time T. What is the sign convention? So we assume that this x direction is positive. And I need to analyze this system for free vibration. So I'm going to give you U2 of 0 is equal to, let us say, U2 of 0 is, let us take it as 100 mm.
Yes, sir.
And U1 of 0 is 0. Similarly, U2 dot of 0 is 0 and U1 dot of 0 is 0. So the system starts from rest. Why does the system start from rest? Because velocities at time instant t equal to 0, when observation has started, at that time the velocities of both the masses are 0. Do you agree with me?
Yes, sir.
So the consequence, what do we mean? This means the system starts from rest. Starts from rest. And however, the second mass has been stretched from its mean position towards right by 100 mm. The first mass, however, remains at its mean position. Are you with me?
Yes, sir. You to
U2 of 0, that means the displacement of mass M2 at time t equal to 0 is plus 100 mm. And U1 of 0, that is displacement of first mass at the commencement of
time.
observation, is 0. At time t
Yes.
equal to 0, it is 0. Happy?
Yes, sir.
Okay, let us go ahead now and we are going to solve this problem. Have we derived the equation of motion? Yes, वो तो हमने कल ही कर दिया. Are you with me?
Yes, sir.
So can I write down this equation of motion easily? कैसे लिखना है? तो we have a mass matrix, so I'm going to write it as M1 0 0
0 M2.
yes. Then U1 double dot of T, U2 double dot of T. Happy? Plus K1 K1 plus K2. Then the second element of this matrix is minus K2. This is also minus K2 and this is K2. Do you agree with me?
Yes, sir.
This multiplied by U1, U2.
U2.
Okay. And now let us take here. I'm going to have similar matrix for damping matrix. It is going to be C1 plus C2 minus C2 minus C2 C1 plus C2. Agreed? This
Yes, sir.
multiplied by U1. Oh, I'm sorry. Here you are going to have only C2
C2.
into U1 dot U2 dot of T. This plus this must be equal to F of T. What is F of T? Tell me, what is the force at first degree of freedom? As it is a free vibration, therefore F1 of T is 0. Do you agree with me?
Yes, sir.
And as it is free vibration, even F2 of T is 0. So at all instances of time, these masses are not driven by any force. The system is going to oscillate, however, on account of the initial disturbance to the second degree of freedom. Happy? Are you with me?
Yes, sir.
So this is equal to 0, 0. This is our equation of uh, motion. We call this matrix as mass matrix. We call this matrix as matrix of accelerations.
Acceleration.
We call this matrix as C matrix, that is damping matrix. We call this matrix as matrix of velocities,
Velocity.
plus you have this matrix as K matrix, and we
Stiffness.
call this matrix as, yes, and we call this matrix as matrix of displacements. This is equal to the forcing matrix of forcing functions. Are you with me? You have to understand this F, U, U dot, and U double dot. These are functions of time. Whereas M, C, and K, these are the matrices which are not functions of time. Happy?
Yes, sir.
Okay. Now, what is the value of M1 here? So we will substitute that value. M1 is 1000. What is the value of M2 here? M2 is 1500. What is the value of C1 and C2? C1 is 320, C2 is 480. So what is the summation? 800.
Yes.
So therefore C1 plus C2 is 800. What is the value of C2? C2 is minus 4. C2 is 480. So this is going to be
Minus
minus
480.
480. Yeah. This is also going to be minus 480. And the value of C2 is going to be 480. So जो एग्जांपल हमने लिया उसमें ही हमने इक्वेशन ऑफ मोशन दिखाया है and then we are just substituting the values of various elements in mass, damping, and stiffness matrix. Are you with me, Siddesh?
Yes, sir. Yes, sir.
Yeah, okay. Now let us look at K matrix. For K matrix, we are given the values. K is 10,000, K1 is 10,000 Newton per meter, K2 is 20,000 Newton per meter. So what is the value of K1 plus K2? It is 30,000 Newton per meter. Do you agree with me?
Yes, sir.
What is the value of K2? Value of K2 is 20,000. So this
20,000.
value, this element here is going to be minus
Minus
20,000.
20,000.
This is also minus 20,000. And this is plus 20,000. Agreed?
Yes, sir.
And forcing function, as we said, we are dealing with the free vibration where we have only disturbed second degree of freedom towards right by 100 mm. That is our initial condition. U1 of 0 is 0, U2 dot of 0 is 0, U1 dot of 0 is 0. So system starts from rest. Therefore, this forcing function comes to be 0, 0. Happy?
Yes, sir.
And of course, what are the what are the boundary conditions? I need to mention boundary conditions. Without mentioning these boundary conditions, mathematical definition of this problem is incomplete. So along with this matrix differential equation, this is in fact the set of two differential equations. This matrix representation is set of two differential equations, and to that we have boundary conditions. What is the boundary conditions? U1 of 0, which I call it as U1 0, is equal to 0. Second boundary condition, u2 of 0, which I call it as u2 of 0, u2 0, and this is equal to plus 100. Third boundary condition, u1 dot of 0, which I call it as u10 dot, is going to be 0 because system starts from rest. u2 dot of 0, that is velocity of second mass at time t equal to 0. I call it as u20 dot, and it is going to be equal to 0. Are you with me?
Yes, sir.
So we have to solve this differential equation. And what is the problem that we are facing? The problem that we are facing is these equations are coupled equations. The coupling of the equation is manifested as C matrix and K matrix not being diagonal matrices. Are you with me?
Yes, sir.
Uh, How do you know the equations are coupled? Either of M, C or K matrices, if they are non-diagonal, then it results into the coupling of equations. Kaise? So you can simply do that by expanding the first row. देखो, M1 into U1 double dot plus 0 into U2 double dot. So 0 into U2 double dot मतलब U2 double dot का term नहीं आएगा. So there is no coupling. Are you with me?
Yes, sir.
However, when you expand the second row from damping matrix, you will have 800 into U1 dot minus 480 into U2 dot. So then these equations are coupled. ये equation अगर uncouple decouple करने हैं तो क्या करना पड़ेगा? Somehow I must have this C2 term to be 0. Are you with me?
Yes, sir.
So therefore either K, C और M ये तीनों matrices में एक भी matrix अगर non diagonal है, then we get coupled equations. Mind you, there was no much problem about the mass matrix because it is lumped matrix. So जहां पे हमने degrees of freedom लिए है वहां पे ही सारा mass concentrated है ऐसे assume किया है. So whenever you make the assumption of lumped mass system, you lump the mass only at the degrees of freedom and you consider everything else is weightless. Are you with me?
Yes, sir.
So therefore, lumped mass idealization always leads to diagonal mass matrix. However, that may not be true in case of continuous system. For example, you may imagine a load-bearing system where we consider wall as a part of structural element. So the mass is not only distributed at floor level, it is not only lumped at floor level, it's also distributed along the wall. Do you agree with me?
Yes, sir.
So in that case, if you have to model a load-bearing structure's response to a seismic excitation, you cannot go ahead with lumped mass system. Are you with me?
Yes, sir.
Lumping the mass is feasible only for frame structures. And why it is feasible? Even in frame structures, you have a wall, but that wall is not considered as a structural element. Its mass or its weight is transferred to the beam below, and that means it is transferred to the floor. Are you with me?
Yes, sir.
So whenever we consider total mass of the structure, we take into account mass of the wall and we lump it to the floor on which that wall is resting. Happy?
Yeah.
Okay. So we will look at those practical details little later, but I just gave you the glimpse. Now, our problem in our hand is how do I diagonalize this C and K matrices? Because if I do that, then the rest of the story I know it. I know how to solve for single degree of freedom system. I will be able to do that. The question lies here is how to diagonalize this C and K matrices. Are you with me?
Yes, sir.
So what is our focus? Decoupling of equations. Are you with me?
Yes, sir.
Decoupling of equations. Now, before we go ahead, can you tell me what is the size of this mass matrix? क्या size है यहाँ पे?
2 by 2.
Yes, it is 2 rows and 2 columns. So the first thing that we observe about mass, stiffness and damping matrices are they are square matrices. They are not rectangle in nature. हो ही नहीं सकता. Are you with me?
Yes, sir.
What is the size of C matrix? 2
2 by
cross 2.
2.
What is the size of K matrix? It is also 2 cross 2. So all the matrices are of equal size. Second observation. They are square. Mass, stiffness and damping matrices have same size. And what is 2 here? Tell me. Degree of freedom. If you are dealing with 2 degrees of freedom, the size of matrix M, C and K will be 2 by 2. If you are dealing with 3 degrees of freedom, the size of mass, stiffness, and damping matrix will be 3 by 2. Do you agree with me?
Yes, sir.
Is that a question or is that a affirmation?
No, I agree with you, sir.
Yeah, okay. So therefore, in general, if you are going to have n degree of freedom system, then what will be the size of M matrix? It will be n cross n. Do you agree with me?
Yeah.
N cross n. What is n here? N stands for degrees of freedom. Happy?
Yeah,
Now,
sir.
quickly tell me, what do you see this acceleration, velocity, and displacement as? These are responses. Do you agree with me?
Yeah, sir.
Whenever you are observing a motion of a body, what are the responses that we are typically interested in? We are interested in acceleration, velocity, and displacement. You may ask, why are you interested in acceleration? Are you with me? The answer for that is very simple. Imagine that you are dealing with a building like hospital building where you have a CT scan machine. On that CT scan machine, prescribed level of ground acceleration is given. So in all such cases, merely knowing the displacement will not be enough. You will be interested to know at what is the maximum acceleration that floor exhibits during a particular earthquake. Are you with me?
Yeah, sir.
Okay. So we are interested in all these responses: acceleration, velocity, as well as displacement. So these are, you have to understand, these are response matrices. And are these regular matrices, or are they column are they column matrices? U double dot is a column matrix. Do you agree with me?
Yes, sir.
U dot is also a column matrix. So when I
Matrix.
say column matrix, means if I write its size, the second part will be 1. Number of columns is 1. Are you with me?
Yeah, sir.
All these matrices are going to be column matrices having number of columns equal to 1. And how many number of rows will these matrices, response matrices, exhibit? They will
Two.
exhibit naturally n number of rows. Here too, but in general it is n, where n is the degree
Yes.
of freedom. Are you with me? So it is n cross 1 matrix, n cross 1
One
matrix.
cross one.
Now tell me, is the multiplication of these two matrices possible? हाँ, नहीं होता तो हम लिखते ही नहीं, but फिर भी cross check करते हैं. This is n cross n, this is n cross n. So how do you check if the matrices can be multiplied? Number of columns of first matrix must match with number of rows of second matrix. Then and only then the multiplication is possible. Do you agree with me?
Yes, sir.
चलो एक क्विक एग्जांपल दिखाता हूं मैं. दिस इज अ डायग्रेस. Imagine that this is a matrix A, B, C, and D, and you have to multiply it with this matrix E cross F. So how do you do the multiplication? It will be A into E. Do you agree with me? Plus B into F is the first element, and second element will be C into E plus
And
D
D
into F.
into F.
Right? So अब जरा
Correct,
मुझे
sir.
बताओ, what is the size of this matrix? 2 cross 2. What is the size of this matrix? 2 cross 1. So number of columns of first matrix matches with number of rows of second matrix.
Second
Not
matrix.
only that, the resultant matrix का size क्या रहने वाला? Resulting matrix will be of the size 2 cross 1, where 2 here is the number of rows of first matrix, cross number of columns of second matrix. Do you agree with me?
Correct, sir.
2 cross 1. Happy?
Correct, sir.
Okay. Now let us try to multiply this matrix. A, B, C, D multiplied by E, F, G. चलो करो multiplication. कैसे होगा multiplication? I will try to multiply A into E. ये तो लिख दिया. B into F लिख दिया. अब इस मैट्रिक्स में there is no element to get multiplied by G. Do you agree with me?
Yes, sir.
You cannot say that it is 0 into G, because even if it is 0 into G, this matrix has to have the third column, and in that third column first row element must be 0. Then only you can say it is 0 into G. Are you with me?
Yes, sir.
So therefore, you see that this multiplication is not possible. Why it is not possible? It is 2 cross 2. It is 3 cross 2. So number of columns of first matrix and number of rows of second matrix are in disagreement. Are you with me?
Yes, sir.
They're not same. So this matrix multiplication is not possible. So having said this was digress. Uh, those who already know about it, forget about it. I just explained. Now, so therefore, n cross n into n cross 1, this multiplication is possible and resulting matrix will be of the size n cross 1. Do you agree with me?
Yes, sir.
So n cross 1 will be the size of mu double dot matrix. Cu double dot also has to be n cross 1. Then only these two matrices can get added up. Are you with me?
Yes, sir.
So that is satisfied. And what is the size of force matrix? The size of force matrix will also be equal to n cross 1, where n is number of degrees of freedom. Happy?
Yes, sir.
So though we are solving a problem based on 2 degrees of freedom, whatever we do here can be extended to n degrees of freedom. That's what I want to emphasize. Are you with me?
Yes, sir.
Soon you will realize that this solution itself involves so much complexity that solving a system more than 2 degrees of freedom by pen and paper is impossible. So therefore, whatever we are going to do here, please look at it carefully. Later on, we are going to develop an algorithm to solve multi-degree of freedom system. So, and computer is a dumb machine. As long as you give it a correct algorithm, it will solve the system for you for any number of n. Are you with me?
Yes, sir.
So therefore, any system having degrees of freedom greater than 2, we are not going to solve it by pen and paper. We are going to solve it through a program, which we will develop. Are you with me?
Yes, sir.
Okay. Now, having said that, let us go ahead. Now we are going to attempt decoupling these equations of motion. Are you with me? So, अभी कैसे देखो, if I look at this system now, it is two differential equations which are coupled. Coupled का मतलब क्या है? Each of this differential equation will involve terms in u1 dot, u2 dot, and terms in u1 and u2. Happy?
Yes, sir.
So therefore, these equations cannot be solved. Once we attempt decoupling of these equations, we convert this into two differential equations which are uncoupled. इसका मतलब क्या है? The first equation will be in terms of u1 double dot, u1 dot, and u1. And second equation will be in terms of u2 double dot, u2 dot, and u2. And now we are equipped with solution of this. This is precisely, it is two single degree of freedom systems. Are you with me?
Yes, sir.
So what is our focus? We are going to convert 2 degree of freedom system into two sets of single degree of freedom systems. Are you with me?
Yes, sir.
And then we know everything about single degree of freedom system. We can solve for it. So if we have n degree of freedom system, our focus here will be to convert this into n sets of single degree of freedom systems. Are you with me?
Yes, sir.
तो एक ही चीज मैंने आपको अलग अलग नजरिए, so whichever book you read, you will find the language which will contain either of these explanations जो मैंने अभी तक किया है. Are you with me?
Yes, sir.
At this stage itself, I will discourage you to read the books because अभी तक आपने वो competency develop नहीं हुई है. At one stage, I will allow you to read the books. At that stage only read the books. Otherwise, you will get confused by notations. चलो अब आगे चलते हैं. Now, I'm going to do now a mathematical trick which will decouple these equations of motion. And what is the trick? I'm going to say that let me call this matrix U, which has size 2 cross 1. Do you agree with me? इसके
Yes,
एलिमेंट्स कौन से हैं? u1 of t and u2 of t. Are you with me? These
yes,
are
sir.
the elements of this U matrix. I will claim that I am going to apply a transformation where this U can be represented as phi of Z, where the elements of Z matrices are Z1 of T, are you with me, and Z2 of T. Mind you, these all are matrices of functions. Every element in this matrix evolves with time. Do you agree with me?
Yes, sir.
कौन से matrix? U and Z. However, every element in phi matrix is independent of time. So this is not a function of time. Not a function of time. Are you with me? Is my claim. Happy?
Yes, sir.
What is Z1 of t and Z2 of t? These are two time dependent functions which I am going to call as generalized displacement. क्या बोलेंगे इसको? Generalized
Displacement.
displacement at first degree of freedom in generalized coordinate system. Generalized coordinate system. So जो 2 degree of freedom system था, u1 of t and u2 of t, these were the degrees of freedom that has been transcended into two single degree of freedom systems where z1 of t is generalized displacement at first degree of freedom in that generalized coordinate system, and z2 of t is generalized displacement at second degree of freedom in that generalized coordinate system. Are you with me?
Yes, sir.
Okay. And this is equal to phi times z. So u is equal to phi times z. Now, what is the size of u matrix? It is 2 cross 1. What is the size of z matrix? It is also 2 cross 1. What will be the size of phi matrix? Tell me.
Phi matrix, sir.
Huh.
2 by
What?
2, 2 cross 2.
Yes, correct. So only and only when it is 2 cross 2, you have number of rows of first matrix matching with number of columns of other matrix, and resulting matrix will be 2 cross 1, which is u. Happy?
Yes, sir.
So I have applied this transformation. What is phi? वो अभी तक हमने बोला नहीं कुछ. Now let me substitute this in the governing differential equation. Governing differential equation कौन सा है? देखो, this is M, which is a mass matrix in parent coordinate system, into U double dot, which is a acceleration matrix in parent coordinate system, plus C, which is damping matrix in parent coordinate system, U dot, which is a velocity matrix in parent coordinate system, plus stiffness matrix K into displacement matrix in parent coordinate system, equal to f of t. I'm sorry, equal to f. Of course, f is a function of time, but this is the matrix f. Happy? Now I'm going to apply this substitution. So what is the substitution that I'm going to make? I'm going to call this U matrix as phi times z. Are you with me?
Yes, sir. Yes, sir.
So what will be U dot matrix? Tell me.
U dot
U dot,
matrix.
as I
M.
said, phi is the matrix of constants. It doesn't have its elements of phi matrix are not dependent on time. I said that just now. So it is like some constant matrix multiplied by the matrix which contains entities which are dependent on time. Are you with me? So will it be
Yes.
phi into z dot, where z dot is the matrix of velocities in generalized coordinate systems. Are you with me?
Yes, sir.
ये समझने में अगर किसी को कुछ तकलीफ हो रही है तो मैं आपको ये लॉन्ग हैंड में लिख के दिखाता हूँ. सो दिस इज यू मैट्रिक्स. डू यू एग्री विथ मी? तो यू मैट्रिक्स कौन सा है? u1 एंड u2. हैप्पी? दिस इज इक्वल टू, लेट मी से दिस एज phi 1, phi 2, phi 3, phi 4. These are the elements which are not dependent on time. This into z1, z2. Happy? Are you with me?
Yes, sir.
Now, I want to get U dot matrix. What are the elements of U dot matrix? U1 dot and U2 dot. Agreed?
Yes, sir.
Let me expand the first row. What do I get? U1 is equal to phi1 Z1 plus phi2 Z2. Are you with me? U2 is equal to phi3 Z1 plus phi4 Z4. Happy?
Yes,
Z3.
sir.
Now, what is U1 dot? Tell me. U1 dot is phi1 Z1 dot
Z1 dot
plus phi2
phi 2
Z2 dot.
Z2 dot
What is U2 dot?
phi 3 Z
Phi3
Z1 dot
Z1 plus
phi
phi4
4
Z2 dot.
Z2 dot.
So can I write U1 dot U2 dot equal to phi1, just a second,
Phi 1 phi
phi1, phi2, phi3, phi4,
phi 3 phi 4
Z1 dot
Z2
Z.
dot.
So can I write U dot equal to phi times Z dot?
Yes,
Are you
sir.
with me? So
Yes, sir.
जहां जहां पे पहले टाइम स्ट्रक्चरल डायनामिक्स सीखते वक्त मैं कंफ्यूज हुआ था वो स्टेप्स आई एम ट्राइंग टू क्लियर इट. ओके, सो नाउ दिस इज u इक्वल टू 5 टाइम्स z, u dot is equal to 5 times z dot. Happy?
Yes, sir.
What is the size of this matrix? 2 cross 1. What is the size of this matrix? 2 cross 2.
2 cross.
What is the size of this matrix? 2 cross 1. Now tell me what is u double dot. Extend similar logic, you will get u double dot as 2 cross 1 matrix of phi,
Phi
which is 2 plus 2 matrix, multiplied by z
Z
double dot,
double dot
where z double dot के terms कौन से है? It is z1 double dot and z2
and
double dot.
Z2 double dot.
So these matrices are matrices of generalized velocities, generalized velocity and generalized acceleration. Are you with me?
Yes, sir.
Having said that, now let me put these elements, let me plug these elements into this governing differential equations. So what do I get? What am I going to substitute for u double dot? Phi
You.
z double. Phi, are you with me?
Yes, sir.
Z double
Z
dot,
double dot.
are you with me?
Yes, sir.
Okay, plus, bull,
Plus
C
C
into
phi.
phi z dot. Happy?
Yes, sir.
Plus k into phi z. The matrices that I write in curly brackets are column matrices, whereas the matrices that I write in square brackets are square matrices. Are you with me?
Yes, sir.
And what happens to right hand side? Nothing, because it is going to be f as it is. Happy?
Yes, sir.
Okay. So observe, देखो, the irony that we have in our hand is Z double dot matrix is in generalized coordinate system. Z dot matrix is in generalized coordinate system. Z matrix is in generalized coordinate system. But this F is in parent coordinate system. Are you with me?
Yes, sir.
हाँ, तो वो नहीं चलेगा. There is no compatibility. So what are we? Oh, mathematically it's correct. But I want to bring that matrix also in generalized coordinate system. Are you with me?
Yes, sir.
Okay. And what do I do? So to do that, I pre-multiply all these terms by phi transpose. क्यों ये मत पूछना, हाँ? वो क्यों वो बाद में बताऊंगा. But I pre-multiply all these terms by phi transpose. But before that, let us cross-check the dimensionality of matrices. What is the size of M matrix? 2 cross 2. Is multiplication between phi and M possible? Yes. Do you agree with me?
Yes, sir. Yes, sir.
What is the result? It is a 2 cross 2
Equal
matrix.
to
This is also 2 cross 1. So the
1.
resultant product will be 2 cross 1. Happy?
Yes, sir.
So ये सेम सारी जगह पे ट्रू है. C and phi matrices 2 cross 2, 2 cross 2. K and phi matrices 2 cross 2, 2 cross 2. Z dot and Z matrices 2 cross 1. Resulting matrix of product of these three is going to be 2 cross 1. Happy?
Yes, sir.
Okay, let us go ahead now. I am going to pre-multiply this equation by phi transpose. The moment I do that, so phi transpose M phi into Z dot. Are you with me? Plus phi transpose C phi. I hope you know what is transpose. Transpose means जो रोज है उनको कॉलम बनाना है, जो कॉलम से उनको रोज करना. Are you with me?
Yes, sir.
Z dot plus phi transpose K phi into Z. Happy? Is equal to phi transpose F. And this phi transpose F, now जो ट्रांसफॉर्मेशन हमने M और C मैट्रिसेस पे लगाया था, वही ट्रांसफॉर्मेशन इसके ऊपर सम टर्म्स में लग गया. So this is called as force matrix in generalized. So this is called as generalized force matrix. Are you with me?
Yes, sir.
What is the size of phi transpose? 2 cross 2. What is the size of F? 2 cross 1. What is the size of product? 2 cross 1. So it is generalized force matrix. Are you with me?
Yes, sir.
Force matrix. यहाँ पे जो कि हमारे फोर्सेस जीरो ही है, तो यहाँ पे जनरलाइज्ड फोर्स मैट्रिक्स एंड पेरेंट फोर्स मैट्रिक्स इज both are going to be 0 0. That is okay, but I am developing now in general the philosophy to analyze multi degree of freedom system. Are you with me?
Yes, sir.
Now my claim is I have taken so much efforts to find phi such that phi transpose M phi is diagonal. I am going to take so much efforts in finding out phi such that phi transpose C phi is diagonal. And I am going to invest so much effort in phi transpose K phi such that this matrix is also diagonal. Are you with me?
Yes, sir.
अगर ये हो जाए, if I am able to find out that magical phi matrix, then I am going to decouple the equation. Do you agree with me?
Yes, sir.
If I am successful in doing that, then whatever I get this as phi transpose M phi, I call it as generalized mass matrix. Are you with me?
Yes, sir.
Generalized mass matrix. If I am successful in diagonalizing C matrix by this transformation, pre-multiplication by phi transpose, and post-multiplication by phi, whatever I get, I am going to call that as generalized damping matrix. Are you with me?
Yes, sir.
And this, of course, is generalized stiffness matrix. Happy?
Yes, sir.
So now generalized mass matrix gets multiplied by generalized accelerations. Generalized damping matrix gets multiplied by generalized velocities. Generalized stiffness matrix gets multiplied by generalized displacement. And this is equal to generalized force matrix. Everything falls in place. अब problem क्या है? Finding out phi. Are you with me?
Yes, sir.
And now I claim this problem definition is not complete yet because I have not transcended boundary conditions in terms of the generalized coordinate system. Do you agree with me?
Yes, sir.
So what are the boundary conditions in parent coordinate system? The first boundary condition is on U1. So I will write U1 0 and U2 0 in matrix form. Do you agree with me?
Yes, sir.
And I will give it a notation of U0. These are initial conditions on displacements of degrees of freedom involved in a system. Do you agree with me?
Yes, sir.
So what is the size of U0 matrix? It is 2 cross 1.
Cross one.
Is U0? U0 in fact is nothing but evaluation of U at time t equal to 0. Are you with me?
Yes, sir.
Okay. So this is the matrix. How do I write it? This must be equal to 5 times Z0. Do you agree with me?
Yes, sir.
Are you with me? This must be equal to therefore 5 times. I will call that matrix as matrix of Z0s. Are you with me?
Yes, sir.
So what is Z0 matrix? Z0 matrix is nothing but phi inverse U0 matrix. Do you agree with me?
Yes, sir.
These are two boundary conditions. Two boundary conditions. Or two initial conditions. I'm sorry. These are two initial conditions. How? Because we are talking about Z1 of 0, which is equal to Z1 0. And you are also going to talk about Z2 of 0, which is equal to Z2 0. As a function of this, as a function of U1 of 0, which is U1 0. Are you with me? U2 of 0, which is U2 0. I
Zero.
am intentionally making all the notations very clear. Are you with me? This transformation occurs through transformation matrix phi. Are you with me?
Yes, sir.
Oh, phi inverse. I'm sorry.
Five.
Phi inverse. So दो conditions तो हो गए. We have mentioned two conditions in generalized coordinate system. What are the other two conditions? U1 dot of 0
Dot of zero.
and U2 dot of 0. This is nothing but U1 0 dot and U2 0 dot. Do you agree with me? Can I
Yes,
write
sir.
it as 5 times Z1 0 dot and Z2 0 dot? Yes. So what is the transformation? Next set of boundary conditions, the matrix of U0
U
dot. U0
zero.
dot. Yeah. So it is 2 cross 1 matrix. This must be equal to phi inverse. I'm sorry. Oh, I'm sorry.
Z
Phi is correct. Phi is correct. Yes. Phi times Z0 dot. Do you agree with me?
zero dot. Yes, sir.
2 cross 2. This is 2 cross 1. How much ever irritating it is, I am going to write down the sizes of matrix. Are you with me? In general, it is
Yes, sir.
going to be n cross 1. This is going to be n cross n. And this is going to be n cross 1. Happy? Are you with me?
Yes, sir.
Okay. So how do I get Z0 dot, which is the required set of boundary conditions? It is
Z
2
zero.
cross 1 matrix. This is equal to phi inverse
Phi inverse into U zero dot.
0 dot. Are you with me?
Yes, sir.
This is 2 cross 1. Happy? So this is
Yes, sir.
remaining set of boundary conditions. These are two boundary conditions. So how many initial conditions? I am very sorry. These are two initial conditions. So how many initial conditions do we have now in our hand?
Four.
These two based on initial displacement and these two based on initial velocities. So total four boundary conditions,
Four conditions.
two differential equations of second degree. Are you with me?
Yes, sir.
So this all together, all this mathematical jugglery together is the mathematical representation of physics of MDOF. Are you with me?
Yes, sir.
Okay. Now, how do I find out phi? So my claim in the sense researchers have proved it. This phi is nothing but this phi can be obtained as the matrix of eigenvectors of matrix M inverse K. Are you with me?
Yes, sir.
What is M inverse? M inverse is inverse of mass matrix in parent coordinate system. What is K? K is the stiffness matrix in parent coordinate system. If I take M inverse K and if I solve the eigenvalue problem for M inverse K, then eigenvectors of this matrix help me in developing phi. How? So let us prove this claim first. Are you with me?
Yes, sir.
हाँ, तो उसके लिए हमें पहले क्या करना पड़ेगा? I will have to first find out M inverse. Do you agree with me?
Yes, sir.
How do I find out M inverse? तो M मैट्रिक्स क्या है जरा देखो. 1000 0 0 1500. Are you with me?
Yes, sir.
1000 0
0.
0 1500. How do I get inverse of this? Your calculators are equipped with the calculations for inverses. Here what I am going to do is I am going to do it on an online tool. Are you with me? I hope my screen is visible to you.
Yes, sir. It is visible. Yes, sir. It is visible.
So inverse. So what we are going to do is we are going to use Matlab here. So online compiler, right? महत्वाचं नाही ना? Okay. So online compiler of Matlab. That's what we are going to use. जो हमने कल यूज किया था lab sessions. Are you with me?
Yes, sir.
So where is that? Do you have that link? Can you put it here? कल मैंने दिया था ना आप लोगों को. Matlab and Octave, if I'm right. Just a second. Mail किया था मैंने, so I will use that link. So first command, I think recording also was stopped. So till now what we have done is we have inputted M matrix, we have taken its inverse, we have taken inputted K matrix, we have found out M inverse K, and now we are trying to find out eigenvalues and eigenvectors of M inverse K. Are you with me? Is my voice breaking for everyone?
Yes, sir.
So it is audible.
It is audible. So let me ask someone else to unmute. Priyan, can you unmute? Priyan Yamani.
Yes, sir.
Yeah, please keep yourself unmuted till the issue is resolved with Siddesh. Siddesh, you can leave the meeting and you can rejoin it. I hope my voice is not breaking. Priyan,
It's clear.
pardon?
Sir, yes, you are audible.
Yeah, okay. So now I'm going to write down the command A is equal to eigenvalue of M1K. So eigenvalue of matrix A, comma, I am going to write it as small b. So let us try to evaluate what is the outcome of this command. So let me execute it. What does it say? Error, b is not defined near line 7 and column 11. What is that? So just give me a second. Okay, so what we will do is now it is almost 11:45, but we are going to continue next lecture because due to medical issue, Shinde sir will not be taking the class. So I will give you a break of 10 minutes. So it's now 11:47. You can come back at 12 o'clock and we will take this forward. Okay? Priyan?
Yes, sir.
Okay. So I'm going to mute myself. I'm going to stop recording. Come back at 12. Okay. So I think let's resume. I hope I'm audible. Priyan, can you unmute?
Yes, sir.
Yeah. Okay. So let us resume. Where is that programming? Okay. Uh, so there was error in that command line. So when you write when you write the command in this fashion, you get eigenvalues and eigenvectors of k. Eigenvalues are stored in B and eigenvectors are stored in A. Are you with me?
Yes, sir.
So what we are going to do is we are going to execute this program. Once I execute this, I get देखो A मिल गया and B मिल गया. So what is B? B is a diagonal matrix which gives you the eigenvalues. So what is the first eigenvalue? 40.00. And what is the second eigenvalue of M inverse K? It is 3.33. Are you with me?
Yes, sir.
Corresponding to these two eigenvalues, you are going to have two eigenvectors. And what will be the size of eigenvectors? It will be n cross 1. Are you with me?
Yes, sir.
So corresponding to 3.3333, you are going to have one eigenvector which will have size 2 cross 1, and that eigenvector is this one, 0.6 and 0.80. Are you with me? Second eigenvalue, second column of A. Happy?
Yes, sir.
Corresponding to the first eigenvalue, which is 40.000, you are going to have one eigenvector, that is 0.89443 minus 0.44721. So this A in fact is putting the eigenvectors one after the other corresponding to each eigenvalue. This is our outcome. Are you with me?
Yes, sir.
And now how do I find out phi? So to get phi from here, what do I do first? First of all, I do not accept eigenvalues as it is. जो eigenvalues आ गए हैं, उनको I will arrange it in ascending order. Are you with me?
Yes, sir.
So first you have to arrange these eigenvalues in ascending order. So what is the first eigenvalue then? It is 3.333 and then 40. Are you with me?
Yes, sir.
Lowest eigenvalue, then greater one, then even greater, so on and so forth. जितने degrees of freedom है, उतने eigenvalues रहेंगे. First of all, rank them from lower to higher. Happy?
Yes, sir.
Now, the lowest eigenvalue is 3.333. Corresponding eigenvector is 0.6 and 0.8. Put that as a first column of phi matrix. Are you with me?
Yes, sir.
So पहली eigenvalue कौन सी है? 3.33. उसके corresponding eigenvector कौन सा है? 0.6 and 0.8. That will be the first column of phi matrix. Happy?
Yes, sir.
Then second eigenvalue is 40. So corresponding to this 40, what is the eigenvector? 0.89443 and minus 0.44721. I have placed that as a second column of phi matrix. This corresponds to eigenvalue 40. Are you with me?
Yes, sir.
And now my claim is, if I obtain phi in this fashion, what will be the size of phi matrix? It will be n cross n. So in this case, it is 2 cross 2. Happy?
Yes, sir.
So if you have 3 degree of freedom system, you are going to have 3 eigenvalues, 3 eigenvectors. Arrange them in ascending order, eigenvalues in ascending order. Corresponding eigenvectors को एक के बाद एक रखो, जो मैट्रिक्स मिलता है वो phi matrix. Happy?
Yes, sir.
Is everyone absolutely clear about the process of getting phi matrix? I hope so. If anyone has a doubt, please ask. So now, just my claim is this phi matrix results in diagonalized phi transpose k phi. So if I use this this matrix as a phi matrix, I get phi transpose k phi to be diagonal. I am going to verify my claim. Are you with me?
Yes, sir.
So what is phi matrix? So phi matrix मैंने यहाँ पे लिख दिया देखो 0.6 0.89443 semicolon 0.8 minus 0.4472. 0.6, 0.89443, semicolon means second row, 0.8 minus 0.4472. Happy?
Yes, sir.
Okay. Then now I am going to take the transpose of this phi matrix. That transpose I am going to call it as phi 1. Happy?
Yes, sir.
So phi 1 is transpose of phi matrix. How do I obtain that? Phi transpose का command ये है देखो, phi और उसके आगे colon. Happy?
Yes, sir.
So let me execute this program up to this. Let us look at what is the value of phi transpose. So phi 1 is 0.6, 0.89. देखो जो 0.6, 0.89443 रो था वो यहाँ पे कॉलम बन गया. हैप्पी?
Yes, sir.
एंड सेकेंड रो था वो सेकेंड कॉलम बन गया 0.8 एंड 0.44721. सो दैट्स करेक्ट. सो दिस इज द कमांड टू गेट द ट्रांसपोज phi. Then what do you call it as? Phi and dash. I don't know, I forgot the name. What do you call this as? Colon? No.
No, sir.
Anyway, so phi 1 is equal to phi 1 is phi transpose. Now let me try out phi 1 into k into phi. It is like phi transpose k phi. Do you agree with me?
Yes, sir.
So let us have a look at what is k phi transpose k phi. Phi transpose k phi, if you look at the first element is non-zero, second element is 2 into 10 power minus 2. Are you with me?
Yes, sir.
So it is very close to 0. Because of rounding off of eigenvalues, you have got it as 2 into 10 power minus 1. Otherwise, you would have got it as 0. Happy?
Yes, sir.
So therefore, I am very sure that this into this, this and these elements are 0. And you have only diagonal elements left. So phi transpose k phi is diagonal. My claim has been addressed. Do you agree with me?
Yes, sir.
We will accept this claim. Why do we accept it? Because we have done the calculations. I have shown you. So what is phi transpose k phi in this particular case? Tell me. Phi transpose k phi. What is the value? That I am going to write it down. So the value of phi transpose k phi is 4400. देखो 10 power 3 है ना? So it is 4400. Do you agree?
Yes, sir.
So I will write it 4400. Are you with me?
Yes, sir.
And this value is 44000. 44000. Happy?
Yes, sir.
And this value is 0. This
0.
value is 0. Happy?
Yes, sir.
Let me check if we have made any error here. Phi transpose k phi should be omega square. Omega is eigenvalue 3.3. So just a minute. Transpose k phi. Let me check eigenvalues once again. 1 minute. Eigenvalues are 40 and 3.333. We will cross verify this independently again. Are you with me? Eigenvalue and eigenvectors online. Inverse of m inverse k. So let me calculate eigenvalues of m inverse k. What is m inverse k? For that I will have to 30 minus 20 minus 13.333 plus 13.33. So I have to compute eigenvalue. Why does it not ask me the dimension? Okay. So what is the value? 30
T.
minus 20. Then you have minus 13.33. 13.333. And
Positive
then you have
13.333.
13.3. Pardon?
Positive 13.333.
Yes. Okay, fine. So where are the eigenvalues? Eigenvalues, value. Okay. It should give me, right, eigenvalues. Mm, okay. Let's do one thing. Let us use another one. So tell me again 30. Please be patient. Minus 20.
20.
Then
Plus
you have
13.33.
minus 13.33.
333. And positive 13.333.
Calculate. Hmm. Eigenvalue is 3.333, and then second eigenvalue is, where is that? Second one is 39. So eigenvalues are correct. Okay, then we have a peculiar situation here. 1 minute. So eigenvalues are correct. Okay, just 1 minute. We will check M inverse is 1 or not. M into M inverse. This should be 1. So let me check if that calculation therefore also is correct. Is value of k correct? We have written k correctly. 30,000 minus 20,000 minus 20,000 plus 20,000. That is also correct. So okay, let us go ahead. Let us see what happens. So phi transpose k5. How much did I get? After execution, I get phi transpose as 44000. Are you with me? So I will
Yes, sir.
write down that. And this is 44,000, if I'm right. 44000, because 10 power 4 है, यहाँ पे 10 power 3. Are you with me?
Yes, sir.
Okay, fine. Let us go ahead with this. So I have got this value k phi transpose k phi. Now what about C matrix? Does this phi successfully diagonalize C by pre-multiplying it by phi transpose and post-multiplying it by phi? Are you with me? So जरा C matrix देखते हैं. Where is our C matrix? In equations of motion, C matrix is 800 minus 480. I will write down the C matrix here. C is equal to, बोलो क्या मैट्रिक्स है? 800 minus 480. Are you with me?
Yes, sir.
Then what is next? Minus 480 and then plus 480. Are you with me?
Yes, sir.
Okay. Sure. So Abid, we are going to do one exercise. Can you also tell me what is K matrix here? So let us also write down K matrix. K matrix is minus 20,000 minus 20,000. Are you with me?
Yes, sir.
Then this is plus 20,000. And this is 30,000.
30,000.
Okay. Now, can you tell me what is the ratio of 30,000 by 20 minus 20,000? 1.5?
So let
Are
me
you with me? 30,000 by 20,000 is 1.5.
5.
So this cancels out and you get this as 1 point, right? Now, what is the ratio of 800 and 480? Can you tell me that? Calculate.
1.666.
So therefore, we will have to alter the problem definition. So let us go back to the problem and let us maintain this ratio as 1.5 for some reason. Are you with me? So if I have to maintain this ratio as 1.5, what should this value be? Tell me.
It's double. No. 480.
We will have to change these values. ये दो values हमें बदलने पड़ेंगे. So let me change those values and we will revise C matrix. Just give me a second. So I will call this C1 as 200. Are you with me? And this as
Yes, sir.
300.
300.
So ये 200
So
and
we can
300.
take it as 600 also. Instead of 480. Previous value.
That
The
is
value.
now.
Yes.
Now, if I do this 200 and 300, what is the value of C1 plus C2? Tell me, it is 500. Are you with me?
Yes, sir.
And then this value becomes
300.
300. But again, that is not satisfied, right? No. So we cannot use that. So if I have to use this 200 and also I have to have some value of C2 such that 200 plus C2 by 200 is 1.5. So tell me the value of C2. So 200 plus C2 is equal to 300. So C2 has to be 100. Are you with me?
Yes, sir.
So let me put this C2 as 100. Will that work? No, that will also not work. Okay, just give me a second. Okay. Oh. Yes. Just a second. If I this is 1000. No, 1000 won't do. This has to be 100. This has to be 2. If we take it as 100 and 200, then what happens? C matrix will become 300, 200. Now it will work. Are you with me? Minus 200 and 200. Are you with me? That this will work. So I will say that this is 300 minus 200. Are you with me? This is minus 200, 200, and this is 300. This is 200. I'm sorry.
200.
So C1 is 100 and C2 is 200. That's what we are going to propose. So what is the C matrix? Chalo. C matrix is, let us write it down. 300 minus 200 minus 200 and 200. Do you agree with me?
Yes, sir.
Now let us have a comparison between K matrix and C matrix. Can I write C matrix as some constant alpha multiplied by K matrix? And what will be that constant? That constant alpha will be equal to 1 by 100 in this particular case. Do you agree with me?
Yes, sir.
देखो, each element of K matrix, if I divide it by 100, I recover this C matrix. Are you with me?
Yes, sir.
If damping follows such kind of property, we call it as stiffness proportional damping. Are you with me?
Yes, sir.
Stiffness proportional damping. Damping. Now, what is the why should damping be stiffness proportional? In general, it may not be true, but we will start with this simplest case where damping matrix is in such a fashion that it leads to stiffness proportional damping matrix. Are you with me?
Yes, sir.
Now, I have already proven to you that phi transpose K phi is diagonal. Do you agree with me?
Yes, sir.
Phi transpose K phi is diagonal. If it is so, what will be phi transpose alpha times K phi? Will it be equal to, as this alpha is constant, can we take this alpha outside and can we write it as phi transpose K phi? Are you with me?
Yes, sir.
And we already know that this is diagonal. So if you multiply a diagonal matrix by a constant, it is going to be diagonal matrix. Do you agree with me?
Yes, sir.
For example, let us say this is diagonal matrix AB00. I multiply it by alpha. So what do I get? I get it as alpha A 0 0 alpha B. So it is also a diagonal matrix. Do you agree with me?
Yes, sir.
So if I choose damping in such a fashion that it is stiffness proportional, the transformation phi that diagonalizes K matrix will also diagonalize C matrix. Do you agree with me?
Yes, sir.
Now, in this particular case, as our damping is stiffness proportional, therefore, phi also diagonalizes C. Do you agree with me?
Yes, sir.
C. Now, even if this phi matrix would have been this C matrix would have been mass proportional damping. That means imagine that you would have C1 here, 0 here, 0 here, and M2 upon M1 times C1 here. So it is mass proportional damping. Then also, this phi will diagonalize that C matrix. Are you with me?
Yes, sir.
So diagonalization of C matrix is possible in two cases. If C is mass proportional, are you with me?
Yes, sir.
Let me call it as beta times M, where beta is constant, or it is stiffness proportional. So I will call it as alpha times K. Are you with me?
Yes, sir.
And linear combination of these two is called as stiffness and mass proportional damping. Even this matrix C, which is stiffness and damping proportional, can be diagonalized by phi. Are you with me?
Yes, sir.
So as long as my matrix C matrix is either mass proportional or stiffness proportional or stiffness and mass proportional, I can diagonalize matrix C by same phi. Are you with me?
Yes, sir.
तो अब हम जब experiments डिजाइन करेंगे damping matrix evaluate करने के लिए, then we will find out its parameters such that it is mass and stiffness proportional. That is one of the way of looking at it. However, if that is not true, then I have to use some other tricks in trade to diagonalize C matrix. Are you with me?
Yes, sir.
So keep that in mind. But in this particular case, as I have taken constructed example where C is proportional to K, therefore phi is also going to diagonalize C matrix. Are you with me?
Yes, sir.
So now let us apply those transformation. So now I need to find out three quantities. कौन से quantities मुझे calculate करने पड़ेंगे? I will have to calculate now phi transpose M phi, which is generalized M matrix denoted by capital M. Phi transpose C phi, which is generalized damping matrix denoted by capital C, and phi transpose K phi, which is generalized stiffness matrix denoted by capital K, and generalized force matrix, which is phi transpose F denoted by capital F. ये चारों मैट्रिक्स मुझे अब कैलकुलेट करना है. Are you with me?
Yes, sir.
And that can be done by just 4 lines in the program. यहाँ पे लिख देता हूँ. So what do I need to calculate? I need to calculate phi transpose K phi, which I am going to call it as K1. What is K1? K1 here is capital K there. It is generalized stiffness matrix. Are you with me?
Yes, sir.
I will have to input now C matrix first. So what is the value of C matrix? C matrix is 300 minus 200 semicolon goes to next row minus 200 space 300. This is the 200.
Sir, 200.
Yeah. So this is damping matrix. Are you with me?
Yes, sir.
Now let us K1 तो हमने calculate किया. Now let us calculate C1. Are you with me?
Yes, sir.
And what that will be? Phi transpose C phi. Happy?
Yes, sir.
Phi transpose C phi. Comma, comma. And then we are going to calculate generalized mass matrix. Mass matrix was already diagonalized, but we need to calculate generalized mass matrix because we have term phi transpose M phi here. So that we are going to calculate as phi transpose M phi. Happy?
Yes, sir.
Let me look at all these three matrices. देखो, K is diagonalized, C is diagonalized, 10 power minus 4, 10 power minus 4 means it's 0. Are you with me?
Yes, sir.
Mass is diagonalized, 1.32 into 10 power 3, 1.1 into 3. However, mass matrix, generalized mass matrix के elements अलग-अलग है. Do you agree with me?
Yes, sir.
So what are we going to do now? We are going to now only put the problem in the perspective. इसका solution के तरफ हम आज जाएंगे and then we will stop it. We will not plot the solution. आज हम सिर्फ उसका solution लिख के छोड़ देने वाले हैं. And tomorrow we are going to plot it. Are you with me?
Yes, sir.
So let me write down these matrices. So what is the first term? It is generalized mass matrix. What are the terms in it? 1, 3, 2, 0. 10 power 3 है ना, तो ये हो जाएगा 1, 3, 2, 0. Do you agree with me?
Yes, sir.
Don't get bored. This is very exciting. Once we solve it, you will understand the crux of the method. Then it is 0, then 0, and then here 1, 1, 0, 0. This is generalized mass matrix multiplied by generalized acceleration matrix. Z1 double dot, Z2 double dot. Are you with me?
Yes, sir.
Plus, now let me write down generalized damping matrix. What is generalized damping matrix? 44 and 440. Happy?
Yes, sir.
44, 440, 0, 0. Multiplied by generalized velocities. Z1 dot, Z2 dot. Happy?
Yes, sir.
Plus. Hold on. Mathematics never walks on a straight path, so I am writing it inclined. Next, what is K matrix?
4400.
44000. No, 4400, and here 44000. 44000 and 0, 0. This is generalized K matrix. This is generalized acceleration, generalized velocity, and generalized displacement. Z1, Z2. Happy?
Yes, sir.
This must be equal to phi transpose into F. So I will have to now write down F matrix. What is F matrix? F matrix is the matrix of zeros. 0, semicolon 0. Do you agree with me?
Yes, sir.
And what is generalized F matrix? I'm going to call it as F1. In our notation, it is capital F. It is phi transpose F. Do you agree with me?
Yes, sir.
So it is phi 1 into F. In this particular case, it is going to be 0. 0. So even generalized force matrix, which is equal to phi transpose F, as F is 0, therefore this matrix is going to be 0, 0. Happy?
Yes, sir.
This is generalized force matrix F. इसमें से कौन से फंक्शन है टाइम के? So this and this, these are functions of time, whereas M, C, K are constants. Do you agree with me?
Yes, sir.
Okay. Now, is this enough? No. Now I have to write down the boundary conditions. So how do I write that? Z0 is equal to, क्या लिखना पड़ेगा? 5 times U0. But what is U0? U0 is the matrix of boundary initial conditions, जो कि हमें यहाँ पे लिखना पड़ेगा. So I will write it as U0. This matrix is what is the boundary condition? First degree of freedom is traced to, second degree of freedom is traced to plus 100, but the first degree of freedom is traced to 0. Do you agree with me at the start?
Yes, sir.
But 100 mm, I need to convert it into meter, so it is 0.1. Do you agree with me?
Yes, sir.
So what is U0? It is 0 and plus 0.1 meter. Are you with me? Be consistent, be careful about the units. If it is the case, then what is Z0? Tell me. Z0 is equal to pi times pi inverse U0. Do you agree with me? Are you with me?
Yes, sir.
Okay. Pi inverse into U0. So do I get Z0? Yes, I got Z0 as 0.0909. So let me write down that this is equal to 0.090909. Right now, I am writing everything that I get. Later on, I may say that I will consider only first 3 digits. पहला ही प्रॉब्लम है, इसलिए जैसे आता है वैसे लिखते हैं. माइनस 0.060984 माइनस 0.060984.
0984.
Are you with me? This is
Yes, sir.
Z10 and Z20. This is equal to Z10, Z20. Happy?
Yes, sir.
And what is Z0 dot? It is phi inverse Z0 dot U0 dot. Are you with me?
Yes, sir.
So I will have to define U0 dot first. तो यहाँ पे define करता हूँ मैं U0 dot. कैसे define करूँगा इसको? U0 dot is equal to 0, 0. Do you agree with me?
Yes, sir.
दोनों 0 थे. And now what is Z0 dot? Z0 dot is equal to phi inverse phi into U0 dot. Okay, U0 dot, right?
Yes, sir.
Execute. So this is going to be 0, 0. So I am sure that this is 0, 0, which is equal to Z10 dot and Z20 dot. So with these boundary conditions, we have stated down the problem. Now let us bring it to the form in which we are acquainted with it. So let us expand first row. Can you expand first row? Tell me what will I get? 1320 Z1 double dot. 1320 Z1 double dot. Are you with me? Plus
Yes,
0
sir.
Z2 double dot. Plus 44 Z1 dot. Plus 44 Z1 dot. plus 0 Z2 dot plus 4400 Z1. Are you with me? Happy?
Yes, sir.
This must be equal to 0. Happy?
Yes, sir.
Did you get the equation in Z1 dot Z1 alone? Yes. And what are the boundary conditions? Z1 0 is how much? Z1 0 is this one. Are you with me?
Yes, sir.
And what is Z1 0 dot? Z1 0 dot is 0. Happy?
Yes, sir.
Can you solve this differential equation? Can you solve this? Yes, we are acquainted with this solution in single degree of freedom system. Are you with me?
Yes, sir.
Replace Z1 by U. You know 1320 U double dot plus 44 U dot plus 4400 U is equal to 0. U0 is this and U0 dot is this. You know its solution. Do you agree with me? Are you with me?
Yes, sir.
So what is the solution? Tell me. Okay, before we go to solution, let us write down the second equation and then we will stop for today. Solution we will do it tomorrow. So 0 Z1 double dot plus 1100 Z2 double dot. So next equation is 1100 Z2 double dot. Happy? Plus
Yes, sir.
440 Z2 dot. 440 Z2 dot. Do you agree with me?
Yes, sir.
Plus, bolo. 44000 44000 Z2. This must be equal to 0 subject to boundary conditions. Z20 is equal to, what is Z20? Do we have
Minus
the value? Yes, it is minus 0.60984. And what is Z20 dot?
0.
Yes, Z20 dot is 0. Can you solve for this? Yes, replace Z2 by U. And you have the techniques to solve this. Do you agree with me?
Yes, sir.
So we will stop at the last point quickly. If you compare this with mu double dot plus cu dot plus ku, can you tell me what is the natural frequency of the system? Root k by m. Do you agree with
Yes,
me?
sir.
What is k here? K is 44. K is 4400. And what is m here? 1320. Do you agree with me?
Yes, sir.
Just do 4400 divided by 1320. Uska square root. Tell me how much it is.
1.825.
1.825.
825.
Now, uh, just do that here. What do you get? It is root k by m. So k is 44,000. Do you agree with me? And divided by 1100. So how much do you get?
6.325.
6.325.
325.
This is called as first natural frequency of MDOF system. With me. And this is called as second natural frequency. Are you with me?
Yes, sir.
जैसे सिंगल डिग्री ऑफ फ्रीडम सिस्टम में एक नेचुरल फ्रीक्वेंसी था, यहाँ पे दो होते हैं. सो आई एम गोइंग टू कॉल दिस एज ओमेगा 1 एंड आई एम गोइंग टू कॉल दिस एज ओमेगा 2. आर यू विथ मी?
Yes, sir.
व्हाट इज फिजिकल सिग्निफिकेंस वो हम जरा बाद में देखेंगे, बट मीनवाइल जस्ट डू वन थिंग क्विकली. स्क्वायर 1.825 and how much do you get? Square it.
3.33.
Do you remember this number? 3.333 square.
Yes.
6.325. How much you get?
40.
40. Do you remember this number? What are these numbers? These are eigenvalues of m inverse k. Do you agree with me?
Yes, sir.
देखो frequency the root k by m है ना. So what is
Yes.
m inverse k? M inverse k in some sense is k by m in matrix form, and that has to be omega square. Do you agree with me?
Yes, sir.
So therefore this is first eigenvalues square, and this is first eigenvalue lambda 1 is square of omega 1, and second eigenvalue of M inverse k is square of omega 2, and that is lambda 2. Are you with me?
Yes, sir.
So what is the summary? When you solve eigenvalue problem for M inverse k, the eigenvalues give you square of their natural frequencies when expressed in radian per second. Are you with me?
Yes, sir.
What is unit of this? It is in radian per second. What is unit of this? It is in radian per second. So more insights on multi-degree of freedom system and solution plotting everything tomorrow. Not tomorrow, in the next class. So we are going to stop here for today. If anyone has any questions, please ask me. Otherwise, put your attendance in the link that we use.